Hi, my name is Shaquetta Johnson, and I'm here to explain my code for homework 6. Um, First, we're going to, of course, end the simulation from the last time. All right, and we're going to look at my four um VHDL codes. Okay, so I guess I should start with the finite state machine, seeing that that's what's controlling everything. Um, I started out, of course, making my entity here, my FSM. I'm giving it reset, clock, and answer because, as you'll see later, that will impact whether our functions will be executed because it's basing off the clock and reset behavior before anything is derived. So, of course, the regular entity, our ports are reset, clock, and answer. The answer in this case is going to end up being the selector in another VHDL code, but let's not get ahead of ourselves. So here I have the reset being 1, then the current state is 0, else if clock event and clock is equal to 1, then the current state is equal to next state. So basically we move on if the reset is 0 and we are on a rising edge. And then we process our current state. And as I said before, when the current state is 0, the next state is 1. And when the current state is 1, the next state is 2. And then the same for 2, 3, 3, 4. And then as we look right here at the answer, this is what I was referring to earlier. This is going to control a segment of our ALU. The answer variable here is going to be linked with the select in this code. So as we move on to the ALU, here are my two 4-bit inputs. Here is my excuse me, my output and the select. So as we process our select and the two variables, this right here is essentially just explaining what operations we're performing. So I chose to stay with the codes that we learned in class. So when the select is 0, 0, I want my ALU to add my two 4-bit inputs. When it's 0, 1, I want them to subtract the second number from the first number. When it's 1, 0, I want it to OR the two 4-bit inputs. And when it is 1, 1, I would like it to AND them. And when it's others, the output would be 0, 0, 0. And that especially helped when I was troubleshooting because I was wondering when I was getting 0, 0, 0. That's how you know when to go back and fix something. Okay, so top level. The top level is essentially the joining of the two. As you can see here, I began my entity top level and I basically gave my two inputs, the reset and the clock, and I named it output 2. And I like to think of this top level entity as kind of like what we're going to end up with. And when I say end up with, I mean that's what's gonna be our waves on the simulation. Okay, but in the architecture, we set the signal to temp 1, and you'll see what I mean by when I was saying linking earlier between the two variables that were like the select and the answer. Um, and then I called on my component ALU right here. It's very, very important that you copy the ports exactly from the entity from like this portion right here is from my ALU VHDL code and the FSM is the exact same thing. And then you end the component calling on both of them. And then we begin and then we instantiate. Component 1 is ALU, component 2 is FSM. Will execute in the correct manner that I would like them to go, and I don't want anyone to get confused because the FSM does control the ALU, but I can put the ALU above the FSM in my code. Okay, so port map is where we are linking all of our inputs, outputs, everything that needs to give us what we want as far as properly controlling that ALU with that FSM. So in the FSM, of course, we connect our reset to the reset, the clock to the clock, and the answer, as I told you before, will end up being our select right here as well. But the answer is also linked to temp1. And then port map for yes, that was port map for FSM. Okay, port map for the ALU. Of course, we link our this is where we link our two 4-bit inputs, and the select is going to be from the temp1 signal, so it kind of flows from the FSM to temp1, and from temp1, that's where we'll get our signal for here. And also this is just linking our output as the answer. Okay, and the test bench. The test bench is designed to make sure it works. So here, let's go to the side. Is it going to let me scroll? Okay, great. So here I did my entity test bench, the architecture. Okay, and now top level is my component. Again, copy it straight from the actual VHDL code. So this top level component is straight from the top level VHDL file. And then we do our ports as we've already done before, as I just said. We end the component, and then we label signals. And the unit under test here is our top level. And of course, the A will equal that. These two 4-bit inputs will equal the same. The reset signal is itself, same with clock and the output. And then this is where we just have our intervals waiting so that we can see the change, between the different events, so we can see the difference on the waveform and how long to wait and all that. Okay, and now for the great stuff. We can start testing. These are two 4-bit inputs that I made that would show easy examples for my four operations. Of course, remember it's add, subtract, or, and. And I chose to do 10 and 3. And then reset this also creates the interval. So what we're gonna do, it's already compiled, but just for the sake of this video, I'll compile all. And of course I have no errors, so what I'm gonna do is I'm going to start simulation. I'm going to go to my test bench. And then I'm gonna go to the wave, gonna add the wave to this so we can have our inputs over here. And then what I'm gonna do is set the interval for 2000 nanoseconds so I can zoom in and really see the behavior of of running it all. And let's see, zoom in and let's go to the beginning. Ooh, let's zoom out a little bit actually. We can see all four. Okay, great. So as I said before, reset must be 0 and the clock will be 1. So here is where I inputted my 000 from the code, and it should change. It should perform an operation every time the clock rises. So the first one, let us see. I don't know what it did with the code, but it is and I mean adding, excuse me. So as I said before, my two numbers are 10 and 3. So when you add 10 and 3 together, you should get 13. Well, right here you'll see my on the rising clock edge it says right here, 1101, which is in fact 13. Okay, and then there's a falling edge, and then here's another rising edge. Okay, this is subtraction. Remember, 10 and 3, 10 minus 3 is 7, and 0111 is 7. And then falling edge, and then rising edge again. And now we are, I do believe, oring. Let me triple, quadruple check that we're doing this. All right, let me check. Okay, yes. So it's oring it, and 10 or 3 will give you 1011, and when you and them, it will be 0010. And just to go bit by bit like I did with the others, or as long as I treat it as kind of addition, like as long as one of the bits is 1, it'll end up with a 1. And with 10 and 3, the only time there's not a 1 in either bit case is in this bit right here. And that's why over here, this is a 0 and the rest are 1s. And then I treat and as multiplication. The only time that you would get a 1 with and is if both of them, are 1, which is why there is a 1 right there. Thank you. Hope you've enjoyed.